Hey kids, Miss Kulkarni here. How about working on some enthalpy calculations in this video? But before that, can we identify a reaction as exothermic or endothermic if enthalpy is given to you? Look at the first equation. This is the enthalpy or heat, and it's on the product side. That means this must be energy released, or it will be an exothermic reaction. Whereas look at the second equation. Over here, heat is on the reactant side. That means heat is consumed. It is used up. So the reaction will be endothermic. Here is the third reaction. And again, the amount of heat is on the reactant side. That means it will be an endothermic reaction. Now in the reaction, we got coefficients for each of the reactants and products. So if you want to find out the heat associated with each of the mole of reactants and products, what do? We simply divide that by the number of moles. So for example, the amount of heat with respect to 1 mole of carbon will be 89.3 divided by 1 mole. We got this 1 mole from over here. In case of sulfur, we got 2 moles. So we divide the heat by 2 moles. And for carbon disulfide, again, the coefficient is 1. So we divide that by 1. Alright, in this equation, we have to find out the amount of heat in kilojoules when 5.66 grams of carbon disulfide CH2 is formed. The first step is to convert the mass into number of moles. And how do we do that? We divide that by the molar mass, which is 76.14. And once we find the moles, we are going to multiply that by the heat per mole for that particular compound. In case of carbon disulfide, that value is 89.3 divided by 1. And when we multiply, our final answer comes out to be 6.64 kilojoules. And now in next problem, we are going to repeat the same process only with respect to sulfur. So let's convert that sulfur into number of moles. When we divide that by molar mass, this is what we get. And we need to multiply now heat per mole for sulfur. And that comes out to be 84.3 divided by 2. And when we work on the problem, the final answer is 23.44 kilojoules. Let's work on one more problem. This is the thermite reaction, and the enthalpy is given to you as negative 849, which tells you the reaction must be an exothermic reaction, and we will write it over there on the product side. So our goal is to find out energy change when we have 25 grams of aluminum reacting. Let's first find out the amount of heat per mole of aluminum. There are 2 moles of aluminum in this balanced reaction. So the heat energy per mole will be simply 849 divided by, and now let's work on the enthalpy change, where we are going to convert 25 grams of aluminum to number of moles. We divide that by the molar mass, which is 26.98, and to that you multiply by the energy per mole, and that gives us the final answer, negative 786.7 kilojoules. I hope you guys enjoyed this video, and I'll see you again in next video. Until then, bye bye.